Okay, the first talk is about cybersecurity in automotive applications. As Mr. Srinivasan Ayyappan. I came to know Srini through our International Telecommunication Union meetings, where we were invited for vehicular cybersecurity conversation. So Mr. Srinivasan Ayyappan was born in India, received his bachelor's, master's in electronics engineering and MBA from Indian universities. He has 20 plus years of experience in avionics and automotive product development, including avionics cockpit displaying architecture, vehicle multimedia infotainment architecture, laser automotive heads-up display, electrical electronics architecture, cybersecurity, and functional safety. Experience in global avionics and automatic manufacturers such as Honeywell, Ford, Jaguar Land Rover, Aston Martin, Toyota, Great Wall Motors, and Tata Motors. Certainly, he has a wide variety of vehicular experience in this particular domain. He is an IEEE senior member for 22 years and as an International Telecommunication Union editor, delivered the ITU SG16FG-VM-WG2 technical report, now accepted as a recommendation, and is also a proposal contributor for multiple working groups. All three reports have been accepted by ITU and published as recommendations. With this, it's a distinguished honor, Mr. Srini, to invite you for this CARS symposium. With this, let's see if we can able to share your slides. Are we going to share the slides? Okay, what? Were you able to share this your slides, Mr. Srini, or?
Good morning, Prakash. Yeah, I'll share my screen.
Can you unmute me?
Can you see my screen?
Yes, we can.
In full screen mode, believe.
Yes, we can.
Yes, we can. Yeah.
Okay. Good morning, everyone. Thanks for inviting me to speak in this conference. So my discussion will be around the automotive applications. So I prepared three portions of this presentation. So one is automotive industry, in manufacturing and production, how the cybersecurity is required and it's implemented, and also connected car cybersecurity. Third one is the in-vehicle cybersecurity. I'll explain you the difference between these two, but my focus will be more on connected cars and in-vehicle. So when I say automotive, you can see what I mean. So it's from OEMs who is manufacturing the vehicles, and tier ones who is manufacturing and supplying the electronic control units or systems to the OEMs or manufacturers. Down the line, you can see when I say automotive, it covers a lot of aspects of the automotive: trains, car sharing, rental, dealership, till down to agriculture. So why I bring agriculture? I think I hear some echo. Okay. So in 2021, we saw during the COVID time, farmers turned to the online forums to find the solutions for their problem. And many dealers were selling components and solutions without OEM's knowledge. So now a lot of vulnerabilities went into tractors and farm equipments. So you can imagine the level of automotive cybersecurity required. Okay, so I'll just start with Industry 4.0. So what in automotive manufacturing and production, when I say Industry 4.0, so 1.0 to 4.0. So 1.0 was only mechanisms, stream power, and Industry 4, what we have is cyber peripherals. So more of Internet of Things and networks. That's how the production currently in the manufacturing. So the ecosystem is more of cloud computing, getting the data, and whatever the production data is a live data. So when you order a car, the car is manufactured by order for order. So every screws, nuts, bolts written your name basically. See, if there is a hack or if there is a compromise, then it's easily cascade down the line. So now we'll be more focusing on cybersecurity and the big data in the manufacturing. So when I say focus in cybersecurity, I'm going to speak about IIoT, Industrial Internet of Things. So I'll be focusing on robotics and how the predictive maintenance and the sensor and connectivity, how it is hacked, compromised, what is the impact is more to research. So this is the system architecture for Industrial Internet of Things. So first level processing will be from the production line, where you have the sensors for the moving the parts and assembling. And the second level of processing happens at cloud server. When we say cybersecurity need to focus on the floor and also off the line at the cloud as well. So there's 7 layers, as most of you know, in most of the networks. So in every layer, do we need cybersecurity? The security is the first thing, then cybersecurity is the next level. Why we need cybersecurity? Say you can see this is a small robot. Okay, this can be hacked to peel or to kill its handler. So it's a small robot, right? It's a very small robot, what it can do. And what about my colleagues? My colleagues are working in this environment. A lot of heavy machineries, big robots around them. What if a hacker hacks and hacks a robot and use the attack? Operator, do you think it's a possibility? Okay, let us guess what. Do you know the first fatality by a robot happened at in the automotive industry? And Ford Motors assembly line, in that robot was the first to kill an operator. He was just starting when the parts retrieval process, due to some mechanical malfunction, instead of retrieving the part, 1-ton robotic arm lunged out and struck him across the head. He died instantly. Okay. So if you see the 5th one, robot crushed a man and deleted the evidence. You can check all these in federal files that is still exist as a record. So it pinned the man up against the own frame and crushed him. Okay, the robot showed there was no malfunctions in any of its movements and there was no memory in its computer. That explains a lot. And this is one of the research topics still. So there should be some evidence, there should be some logging, event log, nothing exists. And more facts, you can talk about a lot of robot attacks. Okay. So now we need to see whether do we need cybersecurity, because when you're working in this environment, surrounded with robots handling heavy equipment, this is at manufacturing. Next one, you can see one of the automotive suppliers were breached by 3 ransomware gangs in 2 weeks. Okay, first Hive, if you see, Hive attack was started just 2 hours after the first attack. So the cumulative effect of this means suppliers could not supply parts to the assembly line. The production line being halted. Every minute of delay cost, say 10 grand for OEM. So if the production is stopped or disturbed for an hour, you can calculate it's $500,000 loss to OEM. So that is the commercial impact. So when an Asian OEM, American business, has hacked, and they're asking for 20 million. Because once it hacks a file, say systems file, or operating system, or driver files, or the over-the-air update software, if it is encrypted, it's immediately we need to decrypt, and it keeps on multiplying even the OTS server. In 2022 February, Toyota shut down its plants due to an hacking issue. So there is a threat to the human, threat to the economy, and threat to the production. And also the big hit will be the brand name of OEM. Once it's hacked, then it's going to disturb the whole brand name of the company. Okay, this is for the automotive industry 4.0 in production. So I'll talk later about the solutions, what's been deployed, and some of the research areas, what the research students have to focus. So next one is the connected car. So the industry is the top level. Next one is the connected car. So what I mean by connected car? So it's not an individual vehicle, what you're driving. So how it is connected with each other, with infrastructure. So connected cars globally is going to be 330. From 330, it's going to be 775 million connected cars. So connected cars is connected with intelligence, talking with each other, talking with the roadside equipment, or talking with the cloud. So connected car is vehicle to person, vehicle to network, vehicle to cloud, vehicle to vehicle, vehicle to infrastructure, and vehicle to grid for charging. So threat vectors in the connected car. So if you're using the public clouds and ISP network, it is possible for eavesdropping, physical attacks due to the sensor confusion in autonomous vehicles, man-in-the-middle attack, and Trojan and ransomware. So high incentive if hacker gain access to connectivity domain and cloud services. So it's possible to extract crypto keys, credentials, map update. So just to think, if a hacker hacks and instead of your actual destination, if it shows undisclosed location. So it can, through this connected car hacking, hacker can deliver bogus traffic information. So he can show disruption of network, and he can track you where you're going. Okay, that is for connected cars. Next, I'll go to the in-vehicle cybersecurity. Why it is very important? Because cars deal with more data. So who is interested in data then? Everyone, right? Competitor is interested in the data generated anywhere, cyber vandal. So if you see also the state-sponsored cyber attack just now mentioned by Senator as well. So November 2021, USA transportation firms hit by hacking. 2020, Hong Kong, Philippines, and Taiwan was hit by hacking. 21 also saw Iran hit by hacking. So we have a big list. And also the black hat actors for profit. There are around in 21, 124 vehicles being faced theft in Canada alone. There's only 200,000 residents. 66 of these thefts involved a keyless entry. 200,000 residents. From them, 124 vehicles being stolen. And out of that, 50% of them by keyless entry. Just program it within 4 weeks of time frame. In under a minute, luxury vehicles can be spotted, compromised, and driven away. So the risk comparison, so who is the high risk, who is doing it for sensation. So you might have seen a lot of movies. So Train at La Ciotat, Great Train Robbery, War of the Worlds. So there are movies coming after robbery, or these incidents follow this robbery. So both happens. Here you can see a lot of these web links showing the real-time cyber threat. So is it all of them are information technology, or at the homes or factories? No, it doesn't. Why it is so? Because cars are becoming a mobile office, second home. We have internet in the vehicle. What is the information it is stored? We are storing, say, national insurance numbers, payment account information, because vehicles have infotainment systems, or systems that can store. They're allowing users to store information. It has the driver health records, pictures and videos. And cars carry what we love most. Okay, that means ourselves first, then family and friends, generally, I would say. Okay, social security number, with that you can find the tax documents, bank account information, because not only in States, in Europe, in China, they use some of the payment gateways like WhatsApp, WeChat, or Weixin to pay to the dealers through the infotainment system. Okay, do we need security? Definitely. Why? A lot of bad things may happen if cars are hacked. It may just give a false alarm. It may trigger an explosion. If you increase the voltage or the current to the batteries. Okay, where we're getting the hackers are getting the information, there are a lot of online portals. If you see this piece of information, there is a darknet selling, say, 1,000 gigabytes of information. They're literally giving actual code itself. And during the COVID time, that's what it increased, do it yourself, right? So that's grown leaps and bounds. And it brought a lot of vulnerabilities into the vehicle or any other system. So if you are driving in a car in a busy road, if someone hacks your vehicle, saying if you are not paying one grand, then you can't drive any further. You're in soup then. Okay, keyless entry. This is how it relays information. There'll be an hacker with a system to relay the hack information. Okay, from home, whoever is having the key, that key will be transmitted to the hacker. So they'll be relayed. So within many hackers have proved within 10 seconds, they can get the keys. So examples of this cyber attacks in vehicle, okay, Jeep, Cherokee, and Chevy Impala, there are a lot of vehicles been hacked in this way. So what happens once we find vulnerability? then need to be recalled. See the number of recalls in every year. If even 5% of them due to compromise in security, it's going to be a huge number, and the brand name is going to get hit. Okay. So not only buyers of the vehicles, but designers of the cars also have loads of questions. Why? How to secure them? We have multiple usage models, different configurations, right? So where to keep or how to position your product is the first. Next one is the product complexity. When you say you buy a car, so for buyers it's a car, but for manufacturers it's assembly of multiple systems. So every system or every ECU, electronic control unit, comes from different suppliers. We only brand them as a car, but the inside parts are not owned by us. So it's supplied by owned by us. Didn't mean we don't own them, but we are not manufacturing the parts. We are only assemblers or integrators. So attack vector can come from how far you can trust the suppliers. So if there is a rogue employee who can compromise an ECU, he can compromise the whole vehicle. Do we need to protect against that? And now we are assembling it. There are a lot of aftermarket products. So aftermarket products are fit after you buy a car. The vulnerabilities or attack surfaces and finding them, rectifying them, it's not an easy task. So if you see during COVID times, due to the supply chain bottlenecks, there's a lot of opportunity for black hat hackers to develop and counterfeit parts, components, and integrated circuits or chips or ICs. Okay, and next one is the vehicle ecosystem. We have multiple ECUs or components within the vehicle. We need to interact with the cloud and also to interface to get diagnostics information or health check. We have onboard diagnostics board. We are connecting the USBs and auxiliary ports. We are using the hard disk, SD card, Bluetooth, Wi-Fi within the vehicle. Do we need to protect against each of these? So that is another complexity. So how, if you see threat to vehicles regarding their communication channels, there's 89% of the vulnerability. Vehicle data and code, 87% is possible. Okay, so we need to analyze as a car manufacturer, as a designer, how best we can protect. And next one is the architecture. So within the vehicle, we have something called electrical electronics architecture, or EEA. Initially, there was individually for every functionality, say wiper, there'll be an ECU. For airbag, there'll be an ECU. For audio, there will be an ECU or electronics control unit. Now, due to an architecture development, it is grouped into domain. Next, we have a centralized architecture, which will be, there'll be a supercomputer. So this architecture also evolving, developing. And for systems and a solution architect who is designing this, it is a big challenge. Once he'll find a vulnerability, he will try to fix it. Immediately, next there'll be a next evaluation. And intra-vehicle networking. Within the vehicle, it is not only simple wires. There's a lot of protocols. We have control area network, a LIN, integrated network, and we have Ethernet. So we have multiple networks and multiple protocols. CAN Lin invented, say, 15, 20 years back, there was no cybersecurity at that time. It was not considered. And within an ECU, within a system, the components are keep changing. Complexities in microcontrollers and components such as capacitors, inductors, and power amplifiers. Integration of the features into the central computing is a challenging task. Okay, so as an OEM or a car manufacturer will not have all the skills required to do the cybersecurity assessment. So the first question will be, how do we do the assessment? The vehicle level, component level, because there is a top-down approach. The vehicle level, you can assess the vulnerability and you can go down to the component, how it need to be protected. Or the bottom up, individually components or systems can evaluate, do the threat analysis and file the vulnerability and build the protection mechanism to go up. So and also is very fragmented, fractured. We do not have uncommon key performance indicators. And also the life cycle of the system is the cars 15 years. How do you protect a car for 15 years? And all components, whatever in the vehicle and the systems protocols should be in the same level. So some of the solutions and the mitigations to these issues. First, we need to understand the cybersecurity or automotive life cycle, and within that cybersecurity life cycle. Okay, from component design. And next one is do the threat analysis, find the vulnerabilities. And find the methods and the objectives of the threat vector, threat agents. And what is the impact of these vulnerabilities? And what is the common exposure library we need to develop? So which is the highest risk? The physical access and also the Wi-Fi, cellular and over-the-air update. When you're updating, it is possible to compromise. And next medium, the Bluetooth key fobs, USBs, and DSRCs, the vehicle-to-vehicle connectivity protocols. And we need to assess whether it's only security, also the safety as well. So the typical attacks we need to understand. So if you modify a protocol or a message, how the vehicle is going to react, how the onboard computer, how to assess this impact. Also, it's a scalable. When you say architecture, that architecture is for a platform. What I mean is for 4 or 5 years, that is the same architecture we are going to use. Every year, architecture cannot be redesigned. So if one vulnerability is found, that vulnerability can be scalable for other vehicle ends as well. So that we have to develop multi-layer defense around the computing, communication, and the networks, the complete process as well. So what we do is that do the deep defense. We do the security by design in hardware layer. So this is for in-vehicle cybersecurity and also connected car to some extent to the industry 4.0 as well in the production line. So the hardware layer, ECUs and modules, the data integrity by code signing or software signing. And we debug port are disabled by a password or it's removed. Security assets are identified, tracked. The software and hardware backdoors are eliminated. And secure communication network and messages are protected and device being authenticated. Network being segregated for critical and the normal functionality, the firewalls being established. So external interfaces have the hardened external interfaces and configurations, and over the air securely delivered. Secure boot, secure operating system, and always trusted execution environment being employed. Keys are handled within or inside the hardware security modules or secure hardware extensions or secure island. The backend is always protected by the public key infrastructure, and the certificate management is done within the HSM or secured area of the micro. Applications being sandbagged between the applications, and every micro being scrutinized for its security characteristics. And there are secure operating system in place. So what we employ is a zero trust security model. So only trusted modules or communication are whitelisted. Otherwise, it's all blacklisted. So there is a data loss prevention, never trust, always will be verified. So this is for industry 4.0. There is a standard how the identification of the material data flow and timely response to event. There are many standards globally. Everyone is working towards data confidentiality, integrity, and authenticity of the processing. IAC. And in Europe, there is a regulation, UNECE, and we have an ISO standard 21434 for cybersecurity in automotive. Okay, research areas are aftermarket products hidden from OEMs, tier ones. So there is no universal mechanism. We need more research to counter cybersecurity threats from this. Remedial tool development is required. Observing the cyber hacker forums. It is crucial to monitor these forums if manufacturers intend to stay one step ahead of the black hat actors. Configurations properties embedded in are used for connected cars, chargers. There are different standards, different manufacturers. There's no research. There's less research how to harmonize this. There is no interoperability, just now, as the senator mentioned. There is no common platform, everybody on their own. There is no consolidated metrics. There is no information sharing. So until otherwise that is there, that will not bring us the confidence. If I do this, this is the outcome. There is no such confidence. There is no such metrics. Security by design is challenging due to the networks. If you see 4G to 5G is going to be huge advancement. Chip design is evolving every 18 months. That the processing power is doubling. That means even if you get an attack, it's going to be processed very quickly. How you mitigate that? Any good or bad are very processed very fast. Okay, I will conclude 2 minutes. Working towards a reasonable required cybersecurity. Data is the basis of connectivity, giving third party unlimited uncontrolled access, in the sense by hacking. Okay, so PII, personally identifiable information, need to be protected. No data has to be designed to be accessed without security, safety, and liability. So always there is a regulatory and supervisory framework, but along with that, it comes to OEMs and suppliers' responsibility. So when a car is hacked, nobody is going to tell the component or an IC is hacked. They're going to say this car is hacked. So the OEMs are taking a huge responsibility burden on cybersecurity. We are continuously training, evaluating, and also evolving ourselves. Cybersecurity is a continuous process. So we are just doing that. Thank you. That's my last slide. If you have any questions.
Okay.
Unmute.
So thank you, Mr. Srini, for a great presentation. I appreciate your insight on discussing about vehicular cybersecurity. While we are gathering questions, maybe I should start with my first question. So, from your discussion with ITU and your experience, do you see, is there any particular sub unit or sub ECUs are more, are seeing larger vulnerabilities, or what is your take on in-vehicle and vehicle-to-vehicle threats? Where do you see the big challenges, within these individual ECUs or the units? How do you see it?
So within the vehicle domain, there is an information system domain where the telematics control unit gather the information, or that this has the SIM card within the vehicle to connect to the cloud. So that is the major port of entry for the hackers. And next is the infotainment system or vehicle multimedia, which stores a lot of information about the user. So that one, and also the ADAS, the driver assistance system. When we are moving towards the fully autonomous vehicles, that's having more kind of possibility to hack and do the more damage. So within the vehicle, so we are classifying the high threat area in telematics ECU, infotainment ECU, and ADAS system. These three are the major port of entry for the hackers.
Okay, great. And I'm looking at other questions. So in terms of standards, do you see where do the manufacturers mostly look for which standards? You mentioned there are so many standards out there. There is a question on, what would you advise for researchers to look for, recommendations? Which standards are mostly looked upon?
NIST, IEC, and ISO standards, and to some extent ITU and IEEE as well.
Great.
So ISO is for automotive. There is a 21434 standard. For functional safety is a 26262 automotive standard. And we have one for industrial automation. There is a standard IEC.
Great. I have one more question from my own group.
Thank you for your presentation, Mr. Srini. Here in the academia, we notice we explore technologies such as the application of blockchain to vehicular networks, specifically VANETs. What do you think is the potential for such disruptive technologies to be applied to this environment?
Inside the vehicle, more of Ethernet and how we do use the blockchain, or how we use the cryptographic material. Outside in the V2V and V2X, this is still not completely researched. So they're still in the baby steps, I would say. It is not completely matured. So previously it was a DSRC, then it was a vehicle V2V network, vehicle to vehicle, and they're using the LTG or LTC. So it is not fully developed and it's still in research stage.
Okay, thank you. I think we're going, in the interest of time, I think we're going to move on. Thank you, Mr. Srini, for your time, and I appreciate. And we have all speakers, the CARS, to appreciate their time and contribution. We're sending out a nice flag, to say thank you on behalf of UND College of Engineering and Mines. So appreciate it. So keep an eye on this while it's coming your way. And thank you, Mr. Srini.
Thank you.